Okay, welcome to this. So here we're going to be looking at Octa system, which is base 8. Fine. So how does Octa work? You can see here. Let me just move this. Now Octa is uses three binary digits, which is 000, 001, 1, sorry, 010, 011, 100, 101, 110, 111, which is if you're doing it, this is 0 is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Right? Now example. Now Octa uses 8 digits with 0 to 7 is 8. So example is 578. You want to convert these to base 10, right? If you're converting these to binary, right, to decimal, sorry. Now this one will be multiplying 8 raised to power 0. Now this will be multiplying 8 raised to power 1, and this is multiplying 8 raised to power 2. So we have as well 5 times 8 raised to power 2 plus 7 times 8 raised to power 1 plus 2 times 8 raised to power 0. That's give us 278 base 10. So let me just copy this because this is how it works, right? This. So we have the binary to 00 down to 111, which is 0, 1, 2, 3, 4, 5, 6, 7. Right? Now, now the hexadecimal system. The hexadecimal system uses 16 symbols, which is 0 to 9 and then A to F. So if we're doing it here, we can have 0000, 0001, 0010, 0011, 0100, 0101, 0110, 0111, 100, 1001, 1010, 1011, 1100, 1101, 1110, and 1111. So if we're doing this, so this this is 1, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, which is the same thing as A, right? Then coming down here, then this is 11, which is the same thing as B. Now this is 12, which is the same thing as C. Is 13, which is the same thing as D. Is 14, which is the same thing as E. Then this 15, which is the same thing as F. Okay, so I don't mind the C and D. Okay, it's 12, which is the same thing as C. Then this is E. Okay, so now if you're given this as a decimal to base 10, it's still the same process where we did octa to base 10, right? So now this f is times in 16 raised to the power 0, and this we multiply 16 raised to the power 1. That's why we have 2 times 16 raised to the power 1 plus 15 times 16 raised to the power 0, which will give you 32 plus 15, which is 47 base 10, right? So as a decimal digit, which is in 4 bits, is making it perfect for representing binary data compactly, right? Now let's look at, I think we have done this one. So let's look at binary to decimal. I think we've done this binary to decimal. Let me just copy the video. So we'll be using these for some calculations later. So you can try your hands on binary to decimal, which have actually worked on that. Let's look at this binary to decimal. Okay, we've done this. Now let's look at decimal to binary. So Use repeated division by 2, write down the remainders and read from bottom to top, right? Remember, if you are asked to convert 13 base 10 to binary, what you need to do is to divide 13, divide by 2. You keep on dividing it until the quotient becomes 0, right? Now you can see when the quotient is actually smaller than the base, it becomes for 0 remainder what? 1. That is what it means here. So now, if you divide this, 13 divided by 2 is 6 remainder 1. Now you bring the quotient back here. You keep on dividing it by the quotient until the quotient, when the quotient becomes smaller here, so it becomes 0 remainder 1. So 13 divided by 2 is 6 remainder 1. 6 divided by 2 is 3 remainder 0. Now you bring down the 3 here. 3 divided by 2 is 1 remainder 1. Then you bring down that 1. 1 divided by 2 is 0 remainder 1. So taking in bottom to up, you have 1101 base 2. That's what we have here, right? Now let's move forward. So we have the binary to octal. The binary to octal is to group binary digits in sets of 3 from right. Now, if there aren't enough bits, has zeros to the left, right? If there ain't enough bits, has zeros to the left. So let me just copy what I did here. This binary. Let me just copy this. Okay, then let's work with it here. Okay. Now you are asked to convert this 100 110 101 to octal. Now, the first thing you need to do is to group them into three, start from the right, right? So we're left with this, we separate them like this, and then let's work with this. Okay, so if you separate them, your 110 is your 110 is 6, the 101 is 5. So the answer is 65 base 8. Now, what if we have this, right? Or what if we have this? What happens? So you group this one, you group this one, we're left with 1, then you add 0 to the left to make it 3. So 0001 is 1. So the answer to this should be like 165 base 8, right? Like this. So what if we have this, right? So you group this one, then you add 0 to the left, and then this becomes 011 becomes 3, right, becomes 3, and then the answer is 365. So that is how it works, right? That is how it works. So let's move to the next one. uh I think we have done this one, right? Okay, we've not done this one. Octa to binary, the one we did was binary to octa, so let's do octa to binary. Okay, octa to binary, I have to convert 48 base 8 to binary. This is very simple. So what we'll do is to separate the numbers like this. So 4, what is 4 in binary? 4 in binary is 100. Now what is 7 in binary? 7 in binary is 111. If you concatenate them together, you have 10011 base 2. So what we have, when they ask you to convert this to binary. Now this is actually not valid because 8 doesn't fall within the range of this, so we have 7. So now 7 in binary is 111, then other 7 is 1. So the answer to this should be 1 1 1 1 1, or true base 2. So what we have 6. So you pick at 6, 6 is actually 110, then 111. That is how it works, and very simple, right? Now let's move to the next one here. Octal to decimal. So multiply each digit by the power of 8, starting from the right. So if you're converting 125 base 8 to decimal, now what you will do is to start from the right down to the left, which will be 5 times 8 raised to the power 0, and this will be 2 times 8 raised to the power 1, and this will be 1 times 8 raised to the power 2. So if you do this, we have 64 plus 16 plus 5 will give you 8, 5 is 10. Right, that is how it works. Okay, now decimal to octal. So use repeated division by 8 and read the remainder bottom to top. So the same way we did for uh, uh, for binary, right? Where we are dividing by 2, for this one we are dividing by 8, right? Now this is decimal. Now you have 65 base 10 to octal. Now if you're dividing it, right, so we have 65 divided by 8, right? Then we have 8, so we have 8 divided by 8, we have 1 remainder 0, and then 1 divided by 8, we have 0 remainder 1, right? So if you're taking from bottom to up, we have 101 based 8. So that is how it works, right? 101 based 8. That is how it works. And this falls in within the range of this 8, right? Now let's look at the binary to hexadecimal. So group binary digits instead of 4 from right. So convert each 4 bits group to each hexadecimal. Now look at this. We have 11111110 to this. So what you do is to group them the same way we did for octa, and then this 111 is actually 15, which is F, and 10010 is 2. 0010, sorry, 0010 is 2, which is this. So if you add them up together, we give you what, F2. Now, what if we have 1 here? What happens, right? So when you separate this into 4, you separate this into 4. Now, it's left with 1, you add zeros to the left hand side, right? So if you're doing this, the 0001 is actually 1, is 1. So the answer would be 1F2. That will be the answer, right? So the same way we did for this, the same way we did for octal. That's how it works. Now let's look at the hexadecimal to binary. Now each hexadecimal digit is equal to 4 binary, right? I think, yeah, we've done this one before. This one is not hard, right? These are not hard. So assuming we want to convert this to binary, which is 2F16, all you just need to do is to find the binary of 2 and the binary of F. So if you're bringing this to check, the binary of 2 is actually uh 0010, and the value of F is this, right? 110. So if you concatenate them together, you have 00101111, and that's what we have here, right? 0010 and 1111, right? That's what we have here. Let me just move this. Right, 0010 and 1111. Okay, now let's look at hexadecimal to decimal, right? Multiply each hexadecimal digit by the power of 16. So if you're converting 3A16 to decimal, what you do is to 8 times 16 raised to the power 0 and 3 times 16 raised to the power 1. Our A is actually 10, so which give you 10 times 6 raised to the power 0, and this is 3 times 6 raised to the power 1, which will give you 48 plus 10, which will give 58 base 10. That's how it works. Now let's look at decimal to hexadecimal. Now you divide repeatedly by 16 and read remainder upward. Divide repeatedly by 16 and read remainder upward. So that's what we have. If you're giving the 255 base 10 to hexadecimal, so you divide by 16. So it will be 255 divided by 16, we have 15 to about the 16 remainder 15. Now this is the quotient. You can see the quotient here is now smaller than is lesser than the base, right? So since less than the base is just 0, remainder the quotient, which is 15, right? That is how it works. So if we're reading up here, we have FF base 16. That is how it works, because 15 is F and 15 is F, which is FF base 16. Now let's look at the last one. Is it last? No, it's not last. So let's look at octa to hexadecimal. Now, octal to hexadecimal has two steps, which is we have to convert to binary first and then binary to the hexadecimal. Now, you're given this convert 158 to hexadecimal. The first thing we need to do is to convert this to binary. So one here is actually, you can see one here 001, then 5 0 1 2 3 4 5. 5 is 101, then 7 is 111, which we now have. If you combine, concatenate them together, we have 001 101 111. Now the next thing to do is to convert binary to x, right? To convert the binary to x. So convert binary to x, yeah. So we have to divide them, which is this, into four places because there's decimals in four places. 1 2 3 4, 1 2 3 4. So we're not left with 0. So we add 3 0 to the left. So we have 4, right? So if you're doing this, so we now have 0. 0110 is what in hexadecimal, right? So let's confirm we have, or let me just bring this down. Let me just bring, because I've already done this before, so that this will not be hard for us. Okay, okay, I think it's this one here. So let me just copy this so I can use it to better explain this very well. So let me just copy this and paste it here. Oh no, to be complete, let me paste it. Okay. So we now have 000. Our 000 is actually 0. So 0010 is 2, 012 is 2. Okay, 0110, sorry. 0 1 2 3 4 5 6. So our 0110 is 6. 0 1 2 3 4 5 6. Our 0110 is 6, right? Then our 1111 is 15, which is F. So this is actually 106F, right? 06F base 16. 06F base 16. So that is the answer. So that is the answer. So it means that 157, if you're combining this, the answer is actually 06F base 16, right? Based on our calculation here. Now let's look at hexadecimal to octa, right? Hexadecimal to octa. The same process, the same step. The first thing you need to do is to convert to binary and then binary to octa. Now let's look at this. Our 2 is 0010 and our F is this, right? Which is, we concatenate them together, which we have 00101111. So now if you're grouping them into three places, 1, 2, we're left to this, we add 0 to the left hand side here. Now it's 000101, and that's what we have here, right? So which is 0, our 101 is 5 and 111 is 7. So our 2F16 is equals to uh 57 base 8. So our next video we're going to be looking at binary addition, subtraction, multiplication, division, right? So thank you and God bless you.